Okay, so I was just thinking about the complex plane, and so it's basically like this. We got the real numbers on the horizontal axis, and it goes to infinity, and over here to negative infinity. But then you've got the imaginary numbers on the vertical axis, which goes to, I guess, infinity I and negative infinity I. And what we before we had this complex axis, before it came around, then we just had all the real numbers, and what it turns out is that the positive real numbers, you square them, and you get another positive number. And so basically, I'm going to put y equals x squared. And so you plug in positive numbers, you get more positive numbers. And but the thing is, you plug in negative numbers and you get positive numbers as well. And so the only thing that can be can actually have a square root are these numbers, whereas over here in the negative side, I should probably use the lines here that are given to me. -1, -2. None of these can be square rooted. But we changed all that with the addition of this complex thing. So we take this, move it over here, and we say, oh, okay. Now the square root of -1 is I. So it goes that way. So square root in that case goes that way. The square root of -1 is I. The square root of -4 is 2I, and so on. So now all of a sudden you have these numbers, and they kind of have a positive and negative, because the weird thing is that square root of -1 is I, but square root of -1 is also negative I. -2I, -3I. So both these positive and negative i's, when you square them, you get, they don't land on each other. That's the weird thing. Like these on the real number line, you square these numbers, they land on each other, right? 1, 2, 3, 4, and 5. You square them, you get more on this axis. But you square I, you go over, it takes you over here. So interestingly, I squared is -1, and negative I squared is also -1. And 2I squared is -4, and -2I squared is also -4. And okay. What's weird is there's no, I guess what I was thinking was, could there be this same property on the vertical line that there exists on the horizontal line? You know, like where only the pink have square roots, but the orange has no square roots. So couldn't it be like over here that's also true, that this would be like the pink and this would be like the orange? But it's not. I mean, and initially, like I thought, well, I might have a square root, but negative I would not have a square root. But it turns out that's not the case. In fact, if I try to find the square root of I, so I can just go and Google this somewhere. Square root of I, and this is very similar to what the square root of negative I is. So What it actually is, square root of I equals square root of 1/2 plus square root of 1/2 I. And so it's a number that's actually right. If I had to place it in the complex plane and put it like right here, that's the square root of positive I. The square root of negative I think, is down here. But in any case, neither one maps onto itself, much less the same way the real number line does. And so even though I thought maybe it would, because of this fact that if I ask for the square root of, let me rephrase. If I ask for the square root of -4, I get plus and minus 2I. So what that tells me is that, well, the 2 still has that same positive negative properties that it had before. Like the square root of 4 equals plus or minus 2. Well, that's not really true. Actually, let me rewrite this. If x squared equals 4, then x equals plus or minus 2. If x squared equals -4, then x equals plus or minus 2I. Over here, I thought maybe this sort of explained, over here on the left side, thought maybe this sort of explained why you had, like, okay, when you square a thing, whether it's positive or negative, it gives you this answer. So whether it's positive 2 or -2, you get positive 4. Well, it seems like, it's the same thing when imaginary. Whether it's positive 2I or negative 2I, you get -4. But that's not really, it's not having the same effect that where it's going back on itself. Like, in other words, if we look at the real number line, and again, I'm going to use a different color of arrow here, but if I square this, it goes more onto this. If I square this, it goes back over here. So everything goes over here when I'm squaring off the real numbers. So whether it's the negative goes here and the positive goes here. But so the imaginary, I was like, it looks the same, right? This looks the same. So whether it's positive or negative, positive 2I or negative 2I, it's going to go. So I thought, well, maybe it'll go here, but it doesn't. Because when you square it, the I goes away, so you're off that number line anyway. So it does not have that same property. The positive and negative both do the same thing, but what they do is not create, so that's a weird truth. The weird truth is real numbers squared are real numbers, but imaginary numbers squared are not. And that is the strange thing that I got to wrap my head around today.